As the optical microscope improved our ability to understand the form and structure of the world around us, the scanning tunneling microscope opens the atomic world for our inspection. In 1988, a scanning tunneling microscope was used as a teaching instrument at the University of Rochester, where instructors were able to more quickly convey difficult concepts involving atomic structure and quantum phenomena, such as electron tunneling. The response from students was overwhelming, and the teaching value of STM became dramatically apparent. Based on the University of Rochester's experience, a project was initiated to develop an STM that was specifically designed for students and first-time industrial users who would benefit from this powerful new technology. Burleigh Instruments is proud to have developed the Instructional STM. This high-performance instrument is designed with Nobel Prize-winning technology and offers the highest resolution imaging and most precise physical measurement available today. The Burleigh Instructional STM represents the next generation in scanning tunneling microscope technology and makes the powerful new capabilities of the STM affordable and practical. It's a rugged instrument that can provide high-quality atomic resolution imaging quickly and easily. The system is designed for routine use with a provided set of samples and for investigative research of other materials. With your Burleigh Instructional STM, you should be able to set up and acquire atomic images of surfaces in a matter of minutes. The Instructional STM comes complete with all the accessories you should need. It includes the STM scanning head, the control electronics unit, true image software, a set of qualified samples and sampling accessories, an operation manual and a comprehensive student workbook, STM system connecting cables and power cord, and a software security key. The Quick Start section of your operation manual provides easy-to-follow, step-by-step instructions and allows you to quickly confirm that your new system is operating properly. Following the instructions in your manual, select the location for your Instructional STM that will allow easy access to the instrument. Be sure to avoid any source of vibration. It may be necessary to place the scanning head on a vibration isolation table or on an insulator such as a simple inner tube with a heavy top plate. Attach the STM scanning head to the control electronics pin connector located on the rear of the unit with the interconnect cable. Position the cable with a slight loop near the scanning head to absorb unwanted vibrations. Install the ADA 3100 data acquisition card from real-time devices in any available slot in the computer. Follow the instructions supplied by the manufacturer. Connect the control electronics to the computer with a ribbon cable and install the security key in the LPT1 port. Without the security key, the software will not run. Attach the power cord, turn on the computer, and install the True Image software. The novel design of the Instructional STM scanning head allows the user to exchange samples and scanning tips in seconds through a small window on the front of the head. Both the tip and sample carriage are held in place magnetically. To begin the sample insertion procedure, remove the sample carriage by grasping the handle and sliding it out. The sample holder is a 1 centimeter aluminum SEM plug which inserts into the carriage and is fixed by a small set screw. Samples are changed simply by removing one SEM plug and replacing it with another. To replace a probe tip, remove the tip carriage from the scanning head and follow the tip wire preparation procedure in your manual. Once the tip wire has been prepared, insert it into the carriage and replace the carriage into the head, making sure not to damage the tip or your sample. The probe tip carriage is attached to a tubular piezoelectric or PZT element for X, Y, and Z raster positioning. The control electronics unit for the Instructional STM uses the concept of negative feedback to keep the sample and tip within a known tunneling distance as the tip is rastered over the sample. In the constant current mode, the tunneling current is sensed as it falls below or rises above the preset reference value, causing a corresponding increase or decrease in voltage to the Z-axis PZT. The correction and the tunneling current signals are then sent to the computer for storage and image display. In addition to the constant current mode, the Instructional STM will operate in a constant height mode for selected imaging applications. The Burleigh Instructional STM controller is easy to operate with its functions divided into 4 sections: tunneling controls, scan and offset controls, tip approach controls, and monitor output signals. The tunneling control section includes an LED display which is used in the setting of bias voltage and reference tunneling current, and for visual monitoring of actual tunneling current and PZT voltage. This section also includes the servo loop controls for the adjustment of time constant, gain, and high-frequency filtering for real-time image optimization, or for change of mode from constant current to constant height. Scan and offset controls adjust PZT voltages to the X and Y PZT elements for imaging different size areas or different locations on your sample. Tip approach controls allow selection of coarse movement of the probe tip for easy sample and tip exchanges, as well as fine movement to begin or end tunneling. These controls ensure a crashless automatic tip approach to tunneling. The monitor outputs allow tunneling current, Z-axis drive voltage, and scan ramps to be monitored with an oscilloscope or used for synchronized experiments. Since the Burleigh Instructional STM operates in ambient air, it's important that the sample be resistant to contaminant molecules that can absorb to the surface and degrade the ability of the STM to resolve atoms. Similar to the sample requirements of scanning electron microscopes, STM samples must be conductive, semiconductive, or treated. Graphite, one of the supplied samples, is a conductive material that is resistant to contamination in air. Following the quick start instructions in your manual, load the graphite sample into the STM head. Using the sample positioning dial, position the sample and tip approximately 1/2 to 1 millimeter apart with a flat portion of the sample under the tip. Refer to your manual for the recommended settings for bias voltage, reference tunneling current, and the servo loop controls. Using the Windows-based True Image Software's pull-down menus, select and load the image file for graphite. Recommended software parameters will be loaded and a reference image will be displayed. Press the coarse retract button to reset the stepper motor. Then press the auto approach tunneling button. Set the LED display to monitor tunneling current. It should read close to 0 until tunneling begins. The automatic tip approach circuitry quickly moves the probe tip within angstroms of the surface. Once tunneling has begun, start a unidirectional scan. The STM image of the surface appears line by line on the screen, virtually in real time. The probe tip sometimes needs to condition itself and remove contaminants. It may take a few minutes to settle. When this happens, the image should improve with time. You can fine-tune the electronic and software parameters of your experiment to optimize the resolution and quality of your images. Image quality is highly dependent on the nature of the surface and the condition of the probe tip. If the image quality is satisfactory, you can save it by pressing the H key on your keyboard. After raw data images are acquired, they can be expanded or enhanced for better interpretation. True Image software can provide 3D images, cross-sectional data, and contrast enhancement. It can also perform sophisticated digital filtering and fast Fourier transforms. The comprehensive workbook supplied with your Burleigh Instructional STM provides detailed instructions on the operation of the system and a guide to help you optimize images. We suggest that you spend time familiarizing yourself with the contents. In addition, the workbook includes an experimental section, background information for students and first-time users, and sample suitability and preparation suggestions. Your new Burleigh Instructional STM represents a powerful new generation of affordable STM systems. Whether you're in industry or education, your system will provide immediate value to you. The powerful new capability made possible by STM technology is now practical for everyone to use. There's no longer a need to wait or wonder about STM. The Burleigh Instructional STM brings scanning tunneling microscopy into the classroom, the teaching laboratory, and to virtually any industrial research laboratory. We at Burleigh are standing by to help.